Welcome back. So we're going to continue where we left off in the previous video. So we have looked at these formulas here, these integral formulas, and so we now started applying them. So let's say that we want to find the indefinite integral or the antiderivative of 6x to the 5 plus 4 divided by x to the 5. Well, recalling that we can integrate a sum term by term, we can first do the following. We can take the integral of 6x to the 5, and then 6 is a constant factor, so that can be taken outside of the integral. So we get 6 integral of x to the 5 dx plus the integral of the second term. And when we take the integral of the second term, 4 being a constant factor that can be taken out, and 1 over x to the 5 can be written as x to the negative 5. So we have 4 integral of x to the negative 5 dx. Now we can apply the power rule for indefinite integrals, which is the integral of x to the 5 would be x to the 5 plus 1 divided by 5 plus 1, which would be x to the 6 over 6. Here we get x to the negative 5 plus 1, which would be negative 4 divided by negative 4. So we get 6x to the 6 over 6 plus 4 x to the negative 4 over negative 4 plus the constant of integration, and this would be x to the 6 minus x to the negative 4 plus c. And finally I'm going to rewrite that as x to the 6 minus 1 over x to the 4 plus c. So this is the general antiderivative of the integrand right here. All right, so now we have the integral of 8 cube root of w minus 6 over root of w dw. So once again, we have a sum here. So we take the integral of the first summand and minus the integral of the second summand. When we take the integral of the first summand here, 8 is a constant factor, so that can be taken outside of the integral. When we take the integral of the second summand, notice that 6 is a constant factor, so that can be taken out. And then root of w is the same as w to the power half. So we have 1 over w to the half, which can be rewritten as w to the negative half. So basically we have 8 integral of w to the, this is w to the power 1/3. Cube root of w is the same as this. And then minus 6 integral of w to the negative half dw. Okay, so now at this point we can apply the power rule again. So basically we get w to the 1/3 plus 1 divided by 1/3 plus 1. And so 1/3 plus 1 is going to be, let me see if I can write on this. So the first one right here is going to be w to the 1/3 plus 1 divided by 1/3 plus 1. So that's going to be w to the 4 w to the 4/3 divided by 4/3, and we can rewrite this as w to the 4/3 times 3 divided by 4, and then minus 6 times this one would be w to the negative half plus 1 divided by negative half plus 1. And so that's w to the half divided by half. And when you divide by half, that's the same as multiplying by 2. So 6w to the half times 2. So w to the half times 2 plus the c. Doing a little bit of simplification here, we get so you see 4 goes into 8 twice, so we get 6w to the 4/3 minus 12w to the half plus a c. And we're going to rewrite w to the 4/3 as cube root of w to the 4, and w to the half is the same as root of w, and then we get a plus c. Okay, so that's the final answer to this question. So here I'm saying if I take the integral of 6x squared times 2x dx, that's not the same as the integral of 6x squared dx times the integral of 2x dx. That is, the integral of a product is not the same as the product of the integrals of the factors, right? So we cannot, if we have a product in our integrand, we cannot take the integral factor by factor. So for example, so notice that the left hand side here is exactly 12x cubed, and the antiderivative of that is going to be 12 times the antiderivative of x to the 3, which is going to be x to the 4/4 plus a c. So that's the same as 3x to the 4 plus c. On the other hand, the integral of 6x squared, would be 6x cubed over 3, which would be 2x cubed, right, plus is constant, and the integral of 2x would be x squared plus c2. So notice that on the right hand side, here we're getting this, and that's equal to 2x to the 5 plus some other terms, but without knowing the other terms, I can already see that the left hand side is 3x to the 4 plus c, the right hand side is 2x to the 5 plus something else, but obviously they are not going to be equal. So the point here is that the integral of a product is not the same as the product of the integrals of the factors. Okay, so the another thing is that if I have a ratio in my integrand, then I cannot take the integral so the integral of a ratio is not the same as the integral of the numerator over the integral of the denominator. So again, here on the left hand side I have 3x, and the integral of that is 3/2 x squared plus c. On the right hand side, the integral of 6x squared, so the integral of 6x squared is going to be 2x cubed plus a constant, and the integral of 2x here would be x squared plus a constant. So on the right hand side here I'm getting this, which obviously isn't the same. So when you divide the numerator by the denominator here, we're going to end up with 2x plus some other terms here. But the point is these two are not the same. So if we have a ratio in our integrand, then we cannot take the integral of the numerator and the integral of the denominator separately in this way. So therefore, the integral of f of x times g of x is not the same as the integral of f times the integral of g, is not the same as, and integral of f of x divided by g of x is not the same as the integral of f of x divided by the integral of g of x. So these two equations, they don't hold, and But similar, the equation did hold when we had the operation here was a addition. Then this equation was true. So here I have the integral of x to the 6 minus x to the 5 plus 3 over x squared dx. Now I know that I cannot just take the I cannot separately take the integral of the numerator and the integral of the denominator here. So what do I do? Well, I'm going to rewrite my integrand in the following way. So I'm going to write it as x to the 6 over x squared minus x to the 5 over x squared plus 3 over x squared. Now x to the 6 over x squared, that's going to be x to the 6 minus 2, which would be x to the 4. Here I'm going to get x to the 3, and here I'm going to get 3 times x to the negative 2. Okay, now I just apply the power rule, so this would be the integral of x to the 4 would be x to the 4 plus 1 over 4 plus 1. The integral of x cubed is x to the 3 plus 1 over 3 plus 1. And the integral of x to the negative 2 would be x to the negative 2 plus 1 over negative 2 plus 1. And so we get x to the 5 over 5 minus x to the 4 over 4 plus 3 times x to the negative 1 over negative 1. And so we get this. So basically I'm rewriting here as negative 3 x to the negative 1 is the same as 1 over x. Okay, plus c. So that is the indefinite integral of this function right here. Okay, so now we have the integral of 7 minus x e to the x over x dx. Take a moment, pause the video, and see if you can answer this on your own. So think about it for a minute or two, and then come back to the video. Alright, so I hope that you have looked at the video, looked at this problem and tried it on your own. So here again we're going to rewrite this fraction as 7 over x minus x e to the x over x, and then here x cancels out, so we have 7 over x, since 7 is a constant factor, it can be taken out, so 7 integral of 1 over x dx minus the integral of e to the x dx. Now integral of 1 over x is, remember, is ln of absolute value of x, and the integral of e to the x is e to the x plus a c. So so that's the final answer. So again, I wrote down the formula for the integral of 1 over x as this in one of the previous slides. Okay, so here's an example. I want to find a function capital F of x such that its derivative is 40 minus 4x and its value at 1 is 350. So again, we are trying to find a function f such that its derivative is 400 minus 4x and its value at 1 is 350. Now let me rephrase that. So capital F is basically the antiderivative of 400 minus 4x, which means capital F is basically the indefinite integral of this guy. So we know that capital F would be the indefinite integral of 400 minus 4x dx, and if we do it term by term, we get 400x minus 4x squared over 2, which would be, so 4x squared over 2 would be the same as 2x squared plus a constant. So this is the general antiderivative of the function 400 minus 4x, and so now we want, so there are infinitely many of them, right? So there are infinitely many antiderivatives of this guy, and capital F would be one of them. We are given that f of 1 is 350, so now we have to choose c so that the value of this function at 1 is 350. Alright, so we want f of 1 to be 350, and then what is f of 1 from this formula that we obtained here? So f of 1 would be 400 times 1 minus 2 times 1 squared plus c. So we get this. We get that in one hand, f of 1 is given to be 350. On the other hand, we can calculate f of 1 from this formula that we obtained. And now we can solve for c. So this is 400 minus a 2, which would be 398. So here we're going to get 398, and here we have 350. So if we solve for c, we get 350 minus 398, and that's exactly negative 48. So c is negative 48, therefore capital F of x is 400x minus 2x squared minus 48, and that is the particular antiderivative of this function that satisfies this initial condition right here. Okay, so now it's an exercise. It's a very similar question to this one right here. So we want to find the particular antiderivative y if the derivative of y with respect to x is 5x to the negative 1 plus x to the negative 4 minus 1, and if y of 1 is 0. Well, the derivative of y is this, so y would be an antiderivative of this guy. So let's find the general antiderivative of this guy. So y would be the indefinite integral of this, and we do that term by term. The integral of the first term would be 5 times, okay, x to the negative 1, that's the same as 1 over x, so the antiderivative of that guy is ln of absolute x. The antiderivative of x to the negative 4 would be x to the negative 4 plus 1 over negative 4 plus 1, but negative 4 plus 1 is negative 3, so we get x to the negative 3 over negative 3. And the integral of negative 1 is just x, negative x, and then plus a constant. So let's clean it up a little bit. So we get 5 ln of absolute x minus 1/3 x to the negative 3 minus x plus c. And further, x to the negative 3 can be written as 1 over x to the positive 3 right here. Okay, so we have found a formula for y of x, but now here we have this parameter c right here. So far we found the family of antiderivatives of this function, and now we have to find the particular antiderivative so that the value at 1 is 0. So we want y of 1 to 0. So in one hand, y1 or y of 1 is 0. On the other hand, I can calculate y of 1 from this formula that we obtained. So y of 1 would be 5 ln of 1 minus 1 over 3 1 cubed minus 1 plus c. So we can do this. So that's got to be 0, and ln of 1 is 0, so that goes away. Here we get negative 1/3 minus a 1, and negative 1/3 minus a 1 would be negative 4/3. And so here we would be getting negative 4/3, and then when we solve for c, negative 4/3 has to go to the other side, so that's going to be positive 4/3. So c is 4/3. So the particular antiderivative that we're looking for then is 5 ln of absolute x minus 1 over 3x cubed minus x plus c, which is 4/3. Okay, so that's the end of this slides, and so I will stop the video here, and I hope to see you in the next one. Thank you.